Figure shows the cross-section view of hollow cylinders A, B, C made from different materials, lead, brass and steel. They briefly fit one another at room temperature. If the cylinders are heated, the cylinder C falls off, while cylinder A becomes tightly wedged to cylinder B. If alpha lead is greater than alpha brass and alpha lead is greater than alpha brass is greater than alpha steel, A, B, C cylinders are likely to be made. We know that C is releasing. It means linear expansivity of C should be the greatest value. Should be greater than B. We can't get it as greatest value. Alpha C should be greater than alpha B. But A is not releasing. It tightly wedged to cylinder B. It means alpha A is greater than alpha B. By using these two relationships, we can compare given alpha values. And we know that initial radius of A is a small value. Therefore, its expansion should be greater than B. Then A could be brass, B could be steel and C could be lead. For the lead, there is a high expansivity. Therefore, it could be released. Then we can get answer is 3. 24. In a certain experiment, the unclamped end of an aluminium rod R of length 2 centimeters to be moved at constant speed 100 nanometers per second. The rate which temperature of the rod increase for this happen is they have given linear expansivity of aluminium. We can consider moving distance per second. It means increasement of length. Delta L equals L1 alpha theta. Increasement of length should be 100 nanometers per second. 100 into 10 to the power minus 9. Initial length 2 centimeters. 2 into 10 to the power minus 2. We have to substitute in SI unit. Then alpha value is 2 into 10 to the power minus 5. Increasement of temperature per second is theta. We have to find theta value. Then we can cancel out 10 to the power minus 7 with minus 9, 10 to the power minus 2. And we can cancel out 10 to the power minus 2 with 100, 1 over 4. It means 0.25 Celsius per second. Then answer is 1. The wheel shown in the figure is made of 3 bimetal PQ strips attached to the axis using radial metal parts. This can be set up to oscillate about an axis perpendicular to the plane of the wheel and passing through the center. The wheel is designed such that oscillating period of the wheel remains same regardless of change of surrounding temperature. Consider the following statement. A. The moment of inertia of wheels should not change with temperature. Yes, it is correct. If the moment of inertia is changing, oscillation period is changing. The shape of wheel should not change with temperature. We can't decide that. We have to consider only moment of inertia. P is incorrect. The linear expansivity of metal P should be greater than Q. We can't decide it. Then only A is true, then answer is 1. A simple pendulum is constructed by suspending a small metal bob with a fine wire of same metal. The period of pendulum at temperature theta 1 is T1. When the pendulum operates a high temperature theta 2, period of pendulum would be linear expansivity of metal is given. Then we can get initial period equals 2 pi root L over G. Final period T1 2 pi root L value is L into 1 plus alpha theta. Temperature difference theta 2 minus theta 1 divided by G. Then we can divide two equations. We can cancel out Lg and 2 pi. Then we can get T1 divided by T1 equals 1 over root 1 plus alpha theta 1 minus theta 2. Then T1 equals T times root 1 plus alpha times theta 1 minus theta 2. We have to remember that expansion of metal bob is not depending to the not involved to the period, because of we have to consider the length of pendulum as the distance from hanging point to center of cavity of metal bob. Center of cavity of metal bob is not changing with its volume. It is the midpoint. When two metal rods A and B at room temperature are heated together and their expansion delta are plotted with increase in temperature delta theta. The two curves are found to coincide with each other as shown in the figure. It could happen only if we can consider delta L equals L1 alpha theta. For any temperature, there is a constant delta L value for both rods. It means this product should be constant. L1 alpha should be constant. Then product of linear expansivity and original length is same for both rods. Answer is 4. L aluminium and L copper respectively represent functional increase in original length of two rods of aluminium and copper when their temperature increased by an amount of theta from the room temperature. Which of the following graphs best represent the variation of L aluminium and L copper with theta? Linear expansivity is given. We can compare linear expansivity. Linear expansivity of aluminium is greater than linear expansivity of copper. Therefore, we can get first one is the correct answer. Length of aluminium should be greater than length of copper. When the temperature of metal rod is increased by 100 degrees Celsius, its fractional change in length is 2.4 into 10 to the power minus 5. The linear expansivity of the metal rod is, I will write the equation, delta L equals L1 alpha theta. Fractional increasement means delta L over L1. Then we can substitute fractional change in length is this one. It is given as 2.4 into 10 to the power minus 5. We have to find linear expansivity. Change of temperature is 100. Then 2.4 into 10 to the power minus 7 per Celsius. It is the alpha value. Then answer is 5.